vast expanse of the cosmos, amidst the darkness and the infinite mysteries, millions of stars twinkle in the distance. But among all that celestial beauty, one star stands out, shining with a brilliance so intense it looks like a finely cut diamond set against the black velvet of the night sky. We call her Venus. To some, she is the evening star, appearing just as the sun sets, and to others, the morning star, herald of the dawn. In ancient civilizations, she was the embodiment of Venus, the goddess of love, beauty, and fertility, a symbol of allure and captivating mystery. But have you ever stopped to wonder, beneath that radiant glow and those soft cream-colored clouds, Venus hides a terrifying secret. The beauty we see from afar is, in reality, the harshest environment in our solar system, a scorching, merciless hellscape. Today, we're going to journey across space and travel back through time to explore the past and dive into the present of this planet. We'll search for the answer to what happened to her. How did the most beautiful planet in the sky become a hell that no living thing could ever endure? Venus is often called Earth's twin. That's because she's remarkably similar to our home in terms of size and mass. Her diameter is about 1,204 kilometers, while Earth's is 12,742, a very small difference. In theory, she should have had the same potential to support life as Earth does. When viewed from space, Venus is wrapped in a thick, pale shroud of clouds that reflect sunlight brilliantly. This is why she's the brightest object in our sky, second only to the moon. These clouds look like a veil of pure white silk, hiding a grim reality beneath. But this physical similarity is just an illusion. If we could step onto the surface of Venus, we would find a world that is nothing like our home. Imagine an atmosphere so dense it would crush you, temperatures hot enough to melt metal, and rain that falls as sulfuric acid. This is the reality of Venus today. The question is, why did a planet so similar to ours, one that should have been hospitable to life, take such a drastically different path? To understand how this catastrophe began, we have to look back at her past. NASA scientists once proposed a fascinating theory, billions of years ago. Venus might not have looked the way she does today. Early climate models suggest that ancient Venus could have had deep oceans covering her surface, blue skies, and temperatures cool enough for life to thrive, much like the early Earth. Imagine that while life was just beginning to evolve on Earth, Venus might have been a warm, welcoming home. She had water, the essential ingredient for life, and an atmosphere that could have supported small organisms for as long as 2 billion years. That's a vast stretch of time, long enough for life to have made significant progress. However, this theory has been challenged by newer research. Some studies from 2024 suggest that Venus may never have had liquid water at all, or if she did, it was very little and for a very short time. They propose that Venus might have been born to be hell from the very start. Being closer to the sun, she received more energy and might have been too hot from the moment she formed for water to ever condense into oceans. Regardless of her true past, most scientists agree there was a major turning point that sent Venus down a completely different path from Earth. One key factor is her incredibly slow rotation. A single day on Venus lasts 243 Earth days, which is actually longer than her year, which is only 225 Earth days. This sluggish rotation might have thrown her cooling system out of balance, causing heat to build up on the side facing the sun for long periods. And that was the beginning of a disaster known as the runaway greenhouse effect. Picture this: back when Venus still had some water. As the temperatures began to rise, perhaps due to changes in solar intensity or geological activity, the oceans started to evaporate. That water vapor is an incredibly powerful greenhouse gas. It trapped the sun's heat within the atmosphere, preventing it from escaping back into space, which caused the temperature to climb even higher. As it got hotter, more water evaporated, creating more vapor, which trapped even more heat. It became an endless cycle, an uncontrollable chain reaction. While the water vapor was trapping heat, ultraviolet radiation from the sun began breaking down the water molecules in the atmosphere, stripping away the hydrogen. Because it's so light, the hydrogen escaped into space, leaving behind oxygen to react with other elements on the planet. At the same time, carbon dioxide was being released from the rocks and volcanic eruptions, building up into a thick, heavy atmosphere. Today, carbon dioxide makes up 96.5% of her entire atmosphere. This dense gas acts like a giant blanket wrapped around the planet, trapping heat with extreme efficiency. The heat building up inside simply has no way out. This was the end of Venus as a potentially habitable world, and the beginning of the era of cruelty we see today. The current state of Venus is like something out of a nightmare, a true inferno in our solar system. Surface temperatures reach a staggering 460 degrees Celsius. That's hotter than the surface of Mercury. Even though Mercury is much closer to the Sun, it's hot enough to melt lead, tin, or even zinc with ease. If you stood on the surface of Venus, you would be incinerated instantly. Then there's the atmospheric pressure, 92 times greater than Earth's. Imagine diving nearly a kilometer under the ocean. That's the kind of crushing force we're talking about. Probes sent there have to be specially designed. And even then, most only survive for a few hours, before being crushed or melted by the overwhelming heat and pressure. Up in the sky, those beautiful cream-colored clouds we see from Earth are actually thick banks of sulfuric acid. The rain that falls is highly corrosive, but because the surface is so intensely hot, the rain evaporates before it ever hits the ground, a phenomenon called virga. This leaves the surface of Venus bone dry and covered in volcanic rock. The winds on Venus are just as strange. About 60 to 70 kilometers above the surface, the upper atmosphere moves at incredible speeds in a process called superrotation. It circles the entire planet in just 4 Earth days. That's 60 times faster than the planet itself rotates. But down at the surface, even though the wind moves slowly, the atmosphere is so dense it feels like moving through a thick liquid, strong enough to roll small rocks across the ground. Humanity has spent decades trying to understand this planet. The Soviet Union's Venera program was a true pioneer, sending over 20 spacecraft to Venus. They were the first nation to successfully land a craft on another planet. In 1970, Venera 7 became the first to land and transmit data back, though it only survived for 23 minutes. In 1975, Venera 9 sent back the first black and white photos from the surface, revealing a landscape of sharp, jagged rocks. And in 1982, Venera 13 sent the first color images and even recorded the sound of the Venusian wind. It lasted 127 minutes, a record that still stands for the longest survival on the surface. Later, NASA's Magellan mission used radar to map 98% of the surface, revealing a staggering number of volcanoes, over 1,600 major ones, more than any other planet in the solar system. 90% of the surface is basaltic rock, and 65% is covered in lava plains, showing that volcanoes played a massive role in shaping the world. Recent discoveries from 2023 and 2024, using that same Magellan data, have found evidence that volcanoes on Venus are still active today. Sif Mons, for example, shows changes on its surface caused by recent lava eruptions. Venus doesn't have plate tectonics like Earth. Instead, she uses a process called resurfacing, massive volcanic eruptions across the entire planet, to release internal heat, completely renewing the surface all at once. This likely happens every few 100 million years. Despite being similar in size to Earth, Venus lacks an internal magnetic field, This is likely because her core isn't moving in a way that creates a dynamo, or perhaps she rotates too slowly. Without a magnetic field, the solar wind, a stream of charged particles from the sun, can easily strip away the upper layers of her atmosphere. This is one of the main reasons why Venus lost almost all of her water. The story of Venus isn't just a tale of a distant planet, it's a warning sent directly to us. Our world today is facing global warming, driven by the buildup of carbon dioxide and other greenhouse gases. Human activities, especially the burning of fossil fuels, have released these gases into our atmosphere in massive quantities. While our situation isn't as extreme as Venus yet, she serves as a clear lesson, a reflection of the ultimate endpoint. She shows us what happens if we allow the balance of our atmosphere to be destroyed, beyond the point of no return. Venus is a reminder that a planet with the potential for life can become a world without hope if the natural balance is shattered. The story of Venus makes you wonder, if the most beautiful thing can become the most dangerous, is there anything like that in your own life? Perhaps a fleeting beauty hides a hidden danger. Perhaps the things we overlook are the keys to maintaining balance. And perhaps, by learning from the past of another world, we can realize the true value of the home we have and protect this beautiful blue planet of ours forever. Before you close your eyes tonight, think about what we can do to preserve this fragile balance.